Welcome to Secret Squared. I'm Cassie Secret. I'm Megan Secret, and today we're going to continue our series on factoring, and we're going to talk about factoring cubes. So let's dive in. So for us looking at factoring cubes, there are certain things that have to happen for us to actually use. Can you pause? I'm going to move the mouse. Okay, sorry. That was rude of me. 3. So when we're factoring cubes, there's a few things that have to happen for us to actually use this method. First thing is we need there to be two terms. Just so it's kind of similar to when we factor the difference of squares, we also need two terms. And again, terms are separated by pluses and minuses, so that's the way that you can count to make sure you have two terms. The second thing we need is we can either have it adding or subtracting those terms together. Now, the most common term you're going to use is the sum or the difference of cubes. When it's talking about sum, it's addition, and when it's talking about difference, it's talking about subtraction. So unlike difference of squares where it has to be subtraction, when we're looking at cubes, it works if it's plus or if it's minus. So you have a little bit more flexibility. Now, what this could look like, you might have something like x cubed plus 8. Now, first of all, if we're factoring cubes, you have to have cubes. X to the power 3 is x cubed. It's x times x times x. And 8 is also a cube because 8 is 2 times 2 times 2. Also, it is two terms because I have those two terms separated by the plus, and the two terms are actually cubes. Exactly. And we have, in this case, this one is a sum of cubes. The other one that could potentially work is something like 8x cubed minus 125. We have our two terms, and they're all cubes. 8's a cubed, x cubed is a cubed, and 125 is also a cube. Yep, and then so from here, what we're going to do is we're going to show you the formulas of how you're able to break up either something that is a sum or a difference of cubes. So starting with the sum of cubes, that's the one where you're going to have addition, that's what the sum is. So the most generic way that we can write it is x to the power of 3, or x cubed, plus y to the power of 3. So for both these terms, the coefficient is just 1. We are looking at just the variables. It's an x cubed, a y cubed. It is kind of the simplest one you're going to see. What you can think about is these are both cubes. We want to think about breaking them down kind of similar to when we broke down the perfect squares. X is really x times x times x. Yeah, so x cubed you get from x times x times x. And for y cubed, you're going to have the exact same thing. You're looking for three things that are all identical that multiply together to get you y cubed. And y times y gives you a y cubed. Yep, and just a reminder, if you're looking and thinking about our exponent rules, when you multiply, you add all those exponents. So that's how it adds up to get the exponent of 3. And then from here, when we are factoring things, we are breaking it down to make it a product of things. We're now multiplying it together. So our final answer will equal x cubed plus y cubed. It's just going to be written where we're multiplying things together instead of just adding them. What I like to think about is I like to think this is the first parenthesis, this is the second parenthesis. In the first parenthesis, we are going to grab one of everything. We're going to grab one x and just one y. And for that, what's really important to note is in this case, the order is going to matter. We're going to grab one of the x's first and then one of the y's second. Now, it doesn't technically matter which of the x's you're grabbing or which of the y's you're grabbing. So then from here, what we're going to do, and we did leave a space here on purpose, we're going to come back to talk about how to fill it in. To fill in this last set of parentheses, that's the most complicated one. We are going to use the way that we broke it up. And the best way to think about it is we are going to be we have a bunch of x's and a bunch of y's. We are going to move from left to right and grab two things at a time as we go. I like to think it's going into the second parenthesis, so two things at a time. Yep. So what we're going to do, we're going to grab x and x. We're going to multiply those together. X times x is x squared. That's what goes first. Then grab the next two things, go from left to right, then multiply them together. X times y, that's just xy. And then for the very last one, let me move this parenthesis bit. We have two y's left. We are going to multiply them together. Y times y gives us a y squared. So again, first parenthesis, we're like grabbing one of each, one of the x's, one of the y's. And then in that second parenthesis, we're kind of chunking things up. We are taking two of everything. There's our first term, there's that second term, and there's that third term, and order does matter. The last part for this is we need to fill in all of the signs, like are we adding, subtracting? Something that shows up a lot for cubes is there's an acronym to help. First thing we can do though is because we are adding, this will tell us what sign we're going to end up using throughout this problem. So right here, we are going to say plus. So it is going to be the same sign. Yep. So that plus, we're going to use this, like Megan said, the same sign that we started with. And then in this slot, we're actually going to put the opposite sign. So even though we had plus, we're now doing the opposite of that. Oops, the opposite of that, so now to subtract. And the last one, we're going to do plus. That one is always positive. Every single time, no matter what. Now, we have an acronym that we like to use for this. If you're looking at the first letter of each word, we have S for same. O, let me use a different color. We have S for same. We have O for opposite, and AP for always positive. We like to call that acronym SOAP, and that's the way to remember which signs you want to use. So this is our formula for when we're doing the sum of cubes. So now that we've looked at sum of cubes, we're going to look at the difference of cubes. So that means we're subtracting. So the only real difference when you're looking at the problem to start for difference of cubes, when we're talking about difference, that means instead of adding our two terms together, we are going to be subtracting them. We're actually going to do almost the same exact steps as above. It's going to look really, really similar. We're going to think of breaking up the x cubed into three things that multiply together to give you x cubed, so x, and x. Three things that multiply together to give you the y cubed, y, and y. Let me fix that 3. That does not look like a great 3. And then the next step is pretty much the exact same. We're still going to have the two sets of parentheses. In the first parenthesis, we're going to grab one of the x's and one of the y's. Again, order does matter. And then go two at a time. So grab the first two terms. When you multiply them, that gets you x squared. Get the next two terms. Then you do x times y, gives you an xy. Exactly. And then the very last two terms, y times y, gets you the y squared. Now, you should notice that these so far are looking identical. Like the process that we're doing is the exact same. Thanks. Yeah, all these terms are the same. The only difference that's going to show up is now the signs are going to look a little different because instead of adding, we're now subtracting. Oops, sorry, we're now subtracting. Exactly. So we're going to still use that SOAP idea, the same, opposite, always positive, because honestly, it helps so much to think about these problems where you get to this step, no matter if it's sum or difference of cubes, you can do it the exact same to get here. And then the only thing that changes is what those signs are. So for SOAP, the S is for the same sign. So do the same sign that you started with, which is a minus. That's our same. For the next one, we have our opposite. So we're going to have our opposite. And since it's the opposite of subtracting, now we're going to have the addition. And then the last one is always positive every single time, no matter if it's sum or if it's difference of cubes. There we go. So that last sign between the xy and the y squared is going to be a plus. And that is going to be the formula for when you're dealing with your difference of cubes. Again, they look almost the exact same. It's just the signs that are flipped here and there. It's those first two signs, yep, that are the opposite. So for our first example, we're going to look at factoring x cubed minus 8. Notes, whenever you are factoring, you always have to look for the GCF first. In this case, we have an x cubed, we have an 8. They both don't have a variable, so there's no variable in the GCF. And this really has a coefficient of 1. This number's 8. So the GCF is really just going to be 1. Because the GCF is 1, we don't really have to do much. Technically, we're dividing a 1 away, but dividing by 1 doesn't change anything. Exactly. So when you have that GCF of 1, you can really skip that step of taking it out. So then from here, it's all about identifying which we're dealing with, either sum or difference of cubes. Because we have a minus here, that means we're talking about the bottom one, which is our difference of cubes. So from here, we're now going to break down both terms just like we did on the last page, because since all of the terms have to be cubes to do difference of cubes, that means you should be able to break it up into three identical things that multiply together to get you x cubed or to get you 8. So x cubed, we actually already did that on the last page. X cubed is x times x times x. 8, that's the first actual number we've had besides a variable. 8 is 2 times 2 times 2. 2 times 2 times 2 gives you an 8. Now from here, we're going to set it up. We have our first parenthesis, our second parenthesis. Reminder, first parenthesis means one of everything. We're going to grab 1x, we're going to grab a 2. And I'm just going to leave the signs for now, though we do have the formula off to the side, so if you see, hey, that's actually negative, you could put that in. I tend to always wait for the end. And then from here, the second set of parentheses is the one that's a little bit more difficult, has a little bit more to it. In that second set, that's when you're going to start grabbing 2 as you move from left to right. So I'm going to grab x times x. You have to go left to right, and you have to multiply them together. Exactly. So x times x is x squared. Then the next one, we're going to take x times 2, which that's going to end up, you can write that as 2x. We like to put the number or the coefficient in front. And then the last one, 2 times 2, is going to get you 4. So we have this first parenthesis, 1 of everything. This is 2 of everything in different orders being multiplied together, going from left to right. And then from here, I'm going to look, our first sign is going to be negative because SOAP tells us we have our same right here. And so the same sign is subtraction. Then we have our positive because that is going to be our opposite sign. The opposite of subtraction is adding. And the last one is always positive every time, whether or not it's adding or subtracting cubes. And what is really important here, we were using our formula to kind of reference what the signs should be. Honestly, a lot of people tend to find it the easiest to just use SOAP to make sure they're getting those correct signs. That way, you're not having to worry about, wait, was this the formula with the plus first or the minus first? Using SOAP to help you remember is incredibly helpful. And that is going to get you your answer. So for our next example, we are going to factor out 64x to the fourth minus 125x. First things first, we have a subtraction. So that is going to be us using this difference of cubes, just like the last one. We have to look, though, before we do anything else, for the GCF first. Every single time, no matter what factoring problem you're doing, you have to look for a GCF. GCF is very important. It shows up a lot. First things first, x to the fourth is not even a cubed because it's not that x to the third. That's kind of our hints that we do actually have a GCF besides 1 and we have to take a variable out. Exactly, because if you tried to break this up with your cubes right now, you're not going to find 3 things that are all identical that multiply to x to the fourth. So look for that GCF. And actually, because both terms have a variable in it, we are going to be able to take a variable out. We're going to pick the smaller of the two. So our GCF is actually just going to be an x because there's nothing in common with the 64 and the 125, besides just a 1. Exactly, so it's just going to be the x. You could write it as a 1x, but you don't have to. So we're going to divide the x from both terms. So we end up with a 64. Now we have an x to the third from the quotient rule, because really we're doing 4. This has an exponent of 1. 4 minus 1 gives us a 3. And then for the right term, it's really minus 125, because those x's that you have are going to cancel out because they're identical on top and bottom. And then just don't forget your GCF needs to stay there. You're just going to keep it on the outside. It's going to keep tagging along in our problem. So we're not going to have to do anything else with it, but it does have to be in our final answer. Now we're going to focus on the inside of the parentheses, and this is actually going to be our difference of cubes. 64, x cubed, and 125 are all cubes. So now we're going to break it up into 3 separate things that multiply together. This is the first time we're seeing a variable that x cubed actually has a coefficient besides 1. If that happens, you can kind of ignore that. 64 is really 4 times 4 times 4. So we have a 4, 4, and a 4. And then focus on the x cubed. That gives us an x, an x, and an x. So if you have that coefficient and the number, just go ahead and take it separately, do the number, and then do the variable. For the 125, that is a perfect cube, and it is 5 times 5 times 5. And then now from here, it's the same steps as the last one, even though the things right here might look a little bit more complicated. We're going to have x. Don't forget the GCF. A lot of people tend to forget to include it in their answer, and that does give you the wrong answer. So that's why right here, I'm just putting it down right here at the beginning before I forget. And then same idea, our first parenthesis is going to have 1 of everything, so we're going to grab a 4x and we'll grab a 5. Again, I'm going to wait for the signs at the end. And then the second parenthesis, we're going to grab 2 of everything going left to right. So we're going to grab 2 of the 4x's, and we do have to multiply them together. Big thing, a lot of people remember x times x is x squared. We also have to do 4 times 4. So we have that 16x squared. Yep. And then for the next one, When we're going again, grab two things at a time, going left to right. 4x times 5. 4 times 5 gets me 20. And then the x is going to tag along. Let me move my parentheses so I have some more space. And then the very last two terms are easiest too, 5 times 5. That's just going to go ahead and get you 25. So again, when we're doing this, it can be really helpful to not be worrying a lot about the pluses and minuses. Just start by filling out the parentheses with these terms, and then at the end, you can come back using SOAP to figure out the pluses and the minuses. So we're going to use that SOAP, the same, the opposites, the always positive. So we're going to have our same. Since we're starting with subtraction, our same is another subtraction sign. This slot right here is going to be our opposites. Because it's subtracting, opposite of that is adding. And the last spot is always positive. Every single time, regardless of if it's a sum or a difference of cubes that you start with. And from there, that's going to end up being your finished answer. Just make sure that you're keeping your GCF in the front, and then you're all good. So for our last example, we are going to factor 2x cubed plus 54y cubed. It looks different because we have different variables, the x and the y, but we're still going to have that same first step where we look for the GCF first. Every single time whenever you factor. So looking at the variables, both of the terms do have variables, but because they are different variables, there actually is not going to be a variable in your GCF. Now, looking at the 2 and the 54, the GCF is actually going to be 2. 2 is the biggest number that divides both 2 and divides 54. So from there, we're going to have to take our GCF and divide it out. So we have 2 divided by 2, that's just going to cancel out, or 2 divided by 2 really just gives you 1. So we're going to have x cubed. And then right here, 54 divided by 2 is going to give us 27. And we're going to keep the y cubed because the variables do not change, the numbers just divide the other numbers. And since we have our GCF, we need that GCF to stay in the front. From here on out, that 2 is really just going to tag along at the front. Yep, and then from here, once you take out your GCF, when you're looking at what's still in the parentheses, this is a great example of the sum of cubes, which is actually the top one. We haven't seen it yet. However, steps-wise, it's pretty much identical to what we've already been doing. The main thing you will just look at is at the very end, you might have some different signs. So since it is going to be the sum of cubes, so cubes, we're going to split it up. 3 things that are identical that multiply to x cubed. This is a very common one you see. You break them all up as x. And then for the next one, when you're breaking it up, again, there's a coefficient that is not a 1, but we can think of it as 27 is 3 times 3 times 3. So each of those branches gets a 3. And then y cubed is really y times y times y. So put a y right there in the front. Yep. So do the number and the variable separately. And then we're going to have that 2. That GCF does have to stay in the front. And our final answer is going to end up being 2 additional things multiplied. And I'm just going to go ahead and give myself more space. I always need my second set of parentheses really big. So for that first parenthesis, we are going to grab one of everything. We're going to grab one of the x's and one of the 3 y's. Order does matter, so we have the x come first, the 3 y's after that. And then we're going to grab 2 of everything for the second parenthesis, going from left to right. Again, that order does matter. So we're going to grab 2 of the x's, and we are going to multiply them together. That's going to be our x squared. Then we are going to have to take our next 2 things. So we have x times the 3y. This is a little funky because there's different variables, but it's going to be 3xy, so those variables really just multiply together. And we do like to write it in alphabetical order to have the x first. If you wrote the y first, if you did 3, then y, then x, you're not wrong. It's just not the typical way that we write it. And then for the very last one, 3y times 3y, 3 times 3 is 9, and then y times y is going to get you y squared. So we have all of our terms in there. Again, this up till now is identical to what we were already doing. Sum and difference of cubes, the steps are very similar. The only part that's different is the signs, the pluses or the minuses that you put in between the terms at the end. So this first term, or this first sign, is still going to be same, but it's the same as adding, so that's why we're going to have a plus sign here instead of subtraction. The next spot, it's still the opposite, but it's the opposite of adding, so now it's subtraction. The last slot is always positive, so that is going to be adding, whether or not we're doing sum or difference of cubes. And again, that last one will always be positive regardless of if you're doing the sum or the difference of cubes. And then once you're writing out your answer, just double check if you had that GCF, make sure it's still there. And there we go, we're all done. Thanks for watching! If you enjoyed this video, please like and subscribe. If you have any other topics you want us to cover in later videos, leave us a comment below. We'll see you next time!